Welcome to another episode of NASA Science Live, an opportunity for you to interact with NASA experts and have your questions answered in real time. I'm your host, Raquel Villanueva, and today we are going to talk about NASA's Psyche mission. If you have questions throughout today's show, you can send them in using the hashtag AskNASA on social media or drop them into the comment box wherever you're watching. The Psyche spacecraft is preparing to launch October 5th to explore a unique asteroid, also called Psyche, orbiting the Sun between Mars and Jupiter. Scientists believe the asteroid may consist of a significant amount of nickel iron metal mixed with rock. It could contain metal from the core of what is called a planetesimal, which is a building block of an early rocky planet. Psyche may offer a unique window into the violent history of collisions that created terrestrial planets like Earth. I am joined today by two Psyche mission experts who are going to help answer your questions about the journey to a metal-rich asteroid. Dr. Carver Beerson is a Psyche postdoc at Arizona State University. Welcome, Carver.
Thank you so much for having me.
And Dr. Rona Oran is the Psyche Magnetometry Investigation Scientist at Massachusetts Institute of Technology. Welcome, Rona.
Excited to be here.
Thank you both so much for joining us to chat about this mission. Now, I have a question for you both to start. This is the first time we are sending a spacecraft to see a metal-rich asteroid. What do you think we will discover about Psyche? We'll start with Carver.
Yeah, one of the exciting things about going to a type of world we've never been to before is there's so many new types of things we might find that we've never seen. For example, some people talked about the possibility of maybe there's iron volcanism, iron volcanoes on Psyche. And we just don't know if they're there or not until we arrive.
It's exciting to see what we might find. Rona, what about you?
Yes, Psyche is indeed a very unique object that we've never explored before. And there are many open questions. The more we look at it through telescopes, the less we know what kind of body it is, the less it fits into our mold of what planets, type of planetary bodies are made of. And uniquely to the magnetometry investigation that I'm involved in is that Psyche presents the possibility to be the first ever detection of a magnetized asteroid. So all asteroids we visited before were not magnetized and made of rock. Because Psyche is metal rich, it may actually be magnetized.
Oh, now, speaking of metal rich, Carver, if we haven't visited this asteroid yet, how do we know that it may be the exposed nickel iron core of an early planetary building block? What observations have contributed to this theory?
Yeah, well, there's two big ones. One is we can look at the mass or the density of Psyche, and it tells us something about what it's composed of. And the other is looking at how light, in particular radio waves, bounce off the surface. That indicates that there's definitely some metal at the surface. We don't know how much is metal. There might still be some rock mixed in, but there's definitely some amount of metal at the surface of Psyche.
And Rona, what could studying Psyche teach us about Earth's own metal core?
Yes, so our core is also made of metal, and we assume it has a lot of heavy metals in it. But it's so deep inside the Earth that we actually have no chance of ever visiting it. So while we do know that we have a core, we don't know exactly how it formed, when it formed, how it generated the magnetic field that we have that protects us from the space environment. And so visiting Psyche would actually be the first time humans, and probably the only time humans will ever have a chance to visit the core.
Wow. Well, we have some questions coming in from viewers watching online. Remember, you can submit using the hashtag AskNASA or by posting them in the comments section wherever you are watching today. So let's get to some of these questions. Our first is from Suizwe Malisea, I hope I'm saying that right, on Facebook, who wants to know what caused the asteroid belt and what broke up the planets. Carver, do you want to start with that?
Sure. So the asteroid belt, in one sense, is kind of the leftover materials from planet formation. So you have a bunch of material that, as the solar system was forming, you had lots of small bits of rock and ice and mostly rock in the inner solar system coming together to build the planets. In between Mars and Jupiter, we have these leftover bits. Some of them formed into larger planetesimals that then would have impacted into each other, scattering apart, breaking into smaller pieces. And it could be that Psyche was one of those larger planetesimals that had a big impact like this. And so it's just the core that's left over for us to go visit now.
That's a great answer. Now, Kaleon X asks, once you get an accurate size of Psyche, do you think you'll be able to have a good estimate of the size of the parent body? Rona, Carver, I don't know which one you wants to take that question.
That's an excellent question. It's a very, very creative question. So yeah, so what we can tell when you see a rock exposed in space, you can tell from the mineralogy how much pressure it sustained and what kind of temperatures it was created in. So you can kind of estimate what pressured it to be that way. And what pressured it is the overlaying layers of the planet, like we have a mantle and a crust. So if you look at the rocks, you can actually estimate, were they created under a lot of pressure? If so, they were created in a bigger planet.
And Rhoda, we have another question coming in for you. Ravion X asks, is Psyche a remnant of the core of a protoplanet?
I think the definition of a protoplanet and planetesimal are kind of like, it depends on how you look at it. So it's basically, if it is a remnant of a core, it is a remnant of a body that grew and grew and grew and started forming a core, but then something happened to it that stopped it and stopped it from being an actual planet like the other planets that we see that are nice and round and have a soil, etc. So it is a remnant of something that was starting to become a planet, if it is a core.
Now, Carver, would you like to add to that?
No, I think that was a great answer.
Perfect. Now let's move on to Juan Pablo Hernandez on YouTube, who asks, how will the mission show us what Psyche looks like, and will we take samples from it? Carver, I can hand that one to you.
Yeah, so the Psyche mission is not going to take samples of the surface, and instead we're going to use a host of different instruments to look at it while we're orbiting the asteroid. So we have 2 cameras that are going to take images in different wavelengths. We have a gamma ray and neutron spectrometer. It's going to give us more information about what that surface is made out of. And we're going to do gravity science as well with the main antenna, essentially looking at exactly how mass is distributed across the surface of the satellite.
Great, thank you. And, you know, people are tuning in live right now, and we've touched on this a little bit, but for those of you just joining us, let's answer Ananda's question. How did you conclude that this asteroid may give clues to rocky planet formation? I don't know, Rona, would you like to take that one?
Sure. So 99% of the asteroid that we see in the asteroid belt are made of rock, and all the asteroids that we visited are made of rock. And actually, metallic asteroids, something that we call M-class asteroids, is something that we haven't really seen. We see them as really, really little dots. We haven't visited them by spacecraft, but as Carver mentioned before, they do reflect the light in a certain way. They do reflect electromagnetic radiation in a certain way that suggests that they are shiny. They're like a metal. So we know that they consist of a lot of metal in them. We don't know exactly how it looks like. Is it a big chunk of metal? Is it metal mixed with rock? But from that, we know that they are very special because most of the material in the universe is not iron and is not nickel. So if you have a big clump of that material all touched together, it's most likely was created inside a planet where everything sank to the bottom. And in order for that to happen, that is planet formation, where you have a lot of material coming together and forming a core and then a mantle and a crust.
And we've been talking about metal, but Rajavil T asks, what kind of minerals is NASA expecting in Psyche? Can we expand on that as well, Rona?
I may defer this to Carver more.
Carver. All right, Carver?
Yeah, I'm not sure exactly what minerals we're going to find, in part because we don't know exactly what that rocky component of Psyche is at this point. And that's one of the things that we want to learn when we get there and use our imaging cameras and spectrometers that bring with.
Great answer. And Juan Pablo Hernandez on YouTube wants to know, how long will the mission be? And will the probe tell us how Psyche was formed? Do you want to take that one again?
Sure. So it's going to take the mission about 5 years to get there. So the spacecraft's going to arrive at Psyche in August of 2029. And we're going to spend a little over 2 years in orbit at different levels, slowly getting closer and closer to the asteroid, learning more as we descend. And what was the second half of that question?
How will it tell us how Psyche was formed?
A lot of that's going to be in really learning what Psyche is. As we said, right now there's so much we don't know. We know there's some amount of metal, but knowing how much metal, how much rock is there, how are they mixed together or not on the surface, and what's the details of that chemistry. Those are the clues we're going to use to try and figure out how Psyche formed.
Great. Now, Rona Carver, we have a bit of a longer question coming in, so I'm going to need your help deciding who's going to answer this one. Four Winds on X asks, how do gaseous elements settle during planetary formation, influencing planetary structures and phenomena? How does the distribution contribute to diverse planetary characteristics across our solar system?
Okay, so when we look at the solar systems being born, we actually don't just see gas, we see gas and dust. And that's really important when you have those tiny grains of dust. And at some point in our solar system, we know that around 4.6 billion years ago, we formed what we call the first solids. So if you look at the universe when it creates stars, it's only gas. But at some point, our solar system started creating little solids that you can still see in meteorites that fall to the Earth, that nothing touched them. You can actually see them just as they were. And from that point on, you can think about it that a lot of grains just like sticking together, have billions of years to do that. And then slowly you start to form the planets. So depending on what kind of dust mixture you start with, that would determine what kind of planet you're going to form. So if you have almost no metal around, you will have less metal in those grains that you would create. And we also see that our planets really, really change where you sample. If you look at the planets that are close to the sun, like Venus and Mercury and Mars and us, they are terrestrial planets, while the planets that are further out from the sun are gaseous giants like Jupiter and Saturn. So all of those things really have this diversity of planets, as you mentioned, and it really depends where you were formed, when you were formed, what was around you when you were formed.
Thank you, Rona. And I have another question for you. Ding Panda on YouTube is asking, being a metal world with magnetic properties or possible magnetic properties, what possible interferences are being planned for already?
Oh, excellent question. Okay, so we are really, really excited about the opportunity to discover that Psyche is magnetized. We don't know if it is, so we really planned the mission, the instruments. We worked with the engineering teams and everyone to really make sure that if there is a magnetic field in those rocks, we would be able to measure it. So we are planning on actually detecting the disturbances as small as they can be, that we can actually detect them. On the other hand, there is a possibility that Psyche would be very magnetized, and then it will form a cocoon around it, what we call a magnetosphere, which is basically the area around the body that is shielded by its own magnetic field and shields out all this space radiation and space particles. So all spacecraft are actually built with shielding on their instruments and on their hull in order to protect them from space radiation and from extraneous magnetic fields. So we've already made sure that if Psyche is magnetized, we're not going to damage the spacecraft.
Right, thank you. Both have been offering some great insights so far. We have some more questions to get to. Luis Pave on YouTube asks, when is the mission launching and on what rocket is it going to be launched on? Carver, do you have an idea?
Yeah, so the plan is to launch on October 5th, and it's going to be launching on a SpaceX Falcon Heavy rocket.
Perfect, thank you. And Jacob on Facebook asks, what methods are used to determine the density of such a cosmological body like Psyche? Rhoda Carver. Rona, do you want to take that?
So mostly how we determine the density of bodies that we see from very far away is actually to determine their size and their mass, and that gives you the density. The size you can kind of get from radio observations, and Carver may want to add to that later. And the density and the mass you can determine by how this body interacts with other bodies next to it. So usually we just look at this body and how it behaves with respect to other bodies using telescopes for a very long time. This is how we do it for planets inside and outside of the solar system, and the same for asteroids. Carver may want to take more about the uh,
Sure.
mass
One of the
sizes.
cool things about what we've been able to do with Psyche is the Arecibo telescope was actually used to send radar signals at Psyche and listen to how they bounce back. And from that, we actually have a pretty good idea of the size and shape of Psyche, at least at a broad scale right now. And that helps with figuring out the size for that density estimate, like Ron was talking about.
Perfect. Thank you. So we have another question from Luis Pavel. He wants to know what instruments are on board the spacecraft. Rona, would you like to try?
Sorry, I didn't hear you.
I was saying, Rona, would you like to take that one?
Yeah. Yeah, so we have three main science instruments. It's the magnetometer that measures the magnetic field. It would be measuring the magnetic field around Psyche and from Psyche, hopefully. We have the imager that will be imaging the surface of Psyche, characterize its surface, characterize craters, any kind of structures on it, geological structures. And we have the gamma ray neutron spectrometer, which is basically a detector that picks up particles that sputter off of the surface because of cosmic radiation. And that helps us determine the chemical content of the minerals that were sputtered from. So, how much iron, how much nickel the surface has. And putting all of this together with the gravity experiment that will be using the high gain antennas and the radio, as Carver mentioned before, for those of you that didn't hear the beginning, putting it all together, we would be able to build the history of Psyche.
You both are doing such a fantastic job answering all these questions. I have one for you, Carver. Hydromic on YouTube asks, why are some asteroids made of metal, but others are not?
That's a great question, and it's part of why we're going to Psyche. This will be the first metal-rich asteroid that we've gone and visited and explored in this way, and that's one of our questions: is how did it get to be this way? We have some ideas, some hypotheses going in, like maybe it was part of a larger planetesimal where this was the core, and then there was some sort of rocky mantle on top that got stripped off in a giant collision, a giant impact. But we don't know if that's what happened or not, and that's why we're going there, is to find out.
And we have one more question for you from Iceland Animations on YouTube. Wants to know, how big is the Psyche asteroid?
Its radiuses are 250 kilometers. So it's about the size of the state of Massachusetts.
I was going to ask for like another reference point for people. Perfect. Thank you so much, Rona. Now, the questions are fantastic. Please keep sending them in. It's incredible. Yeah, it's incredible to see that we're going to visit this mysterious metal-rich asteroid with Psyche. Now, let's take a little bit of a deeper dive into the mission. Seeing that video makes me think about how many individuals are required to achieve a mission like this. Now, I have a question for both of you. In what way has your experience with the Psyche team been the most meaningful? Carver, would you like to start?
Sure. Yeah, so I joined the Psyche team relatively recently, a few years ago. So I was joining in the midst of COVID and everything else that was happening. And it was really wonderful to just how welcoming the team was to me as I was joining on, even though there was all the chaos going on and everyone was in the middle of trying to get the spacecraft ready for launch. There's still so much excitement and so much passion about all the wonderful science that we're going to be doing.
It's great to hear. What about you, Rona?
It's been such an inspiring and exciting experience, really seeing this team come together I joined in 2017, and really seeing the team build and evolve and add people, and then go into COVID and then come back. And somehow we managed to actually build this spacecraft. And it's really like the combination of talking to people and working with people that have so much different experiences than you. And the first time going to see the Psyche spacecraft when it was being built, when it's still at the bare bones, and then seeing it again at JPL, almost ready for launch before being delivered to the Cape. It was really exciting to see it all actually come to life.
Yeah, to see the physical embodiment of what you've been working so hard on.
Yes, absolutely.
All right, thank you. Now let's get to more of your questions online, and please keep sending them in using the hashtag AskNASA or put them in the chat wherever you are watching today. So we have Ron Carlson on YouTube who asks, will Psyche's magnetic field be measured and mapped? Presumably it's very cold and will have some magnetization locked in from at least its collisions. Rona, that sounds like a question for you.
Amazing question. Yes, so we will be measuring the magnetic field. We have designed with all of our collaborators at NASA and at Denmark Technical University and here at MIT, two magnetometers, two semicircular objects that measure the magnetic field very, very delicately, and try to tell if the body that you see here on the video is actually harbor some magnetic field that's locked into the rocks. So these rocks formed inside magnetic field when they were in a molten state, and then they slowly froze and became solid, locking in that magnetic field. And that ancient magnetic field is the field that we are trying to now detect.
Wow, thank you. And Gary Walters on X is asking a question we've touched on before, but if you're just tuning in, he wants to know, will the spacecraft retrieve any materials from the asteroid? Carver?
So we're not going to retrieve any samples from Psyche. We're just going to be using our instruments as we're in orbit to study the surface and get better and better maps of Psyche as we get closer and closer and closer to the asteroid.
Great. And Carver, a few more people are asking, when will this mission be launched?
We're going to be launching October 5th. And then it's going to be about 5 years before it arrives at Psyche itself. So it'll arrive at the asteroid in August of 2029.
Great, thank you. Curtis Horn on YouTube asks, do we know about near-Earth asteroids that are also metallic? Rona?
I don't believe we do. I mean, we could get back to you on that question. I don't believe there are any big ones. Psyche is definitely unique in the sense that it's the largest known metallic object ever observed by mankind. So I don't know if there may be metallic objects near the Earth.
Great.
Some of
Curtis,
them
great
reach us
question.
sometimes because, yeah.
We'll get back to him with an answer.
Yeah.
Thank you. And then Johnny Cheese on YouTube asks, how many cameras are on board and what will the resolutions of the images be?
So the Psyche spacecraft has 2 imagers on board, and the image quality or the resolution is going to get better as we move later on. And as the spacecraft gets closer to the surface, we'll be able to see more detail on the surface. With the best images, we're hoping to be about 5 meters per pixel, or about 15 feet per pixel across on the surface.
And I have another question for you, Carver. Max Shivitz on YouTube wants to know, what's the difference between an asteroid and a protoplanet?
So asteroids we see today in our solar system, most of them are spread out between Mars and Jupiter. Much smaller chunks of rock than the Earth or even our own moon. A protoplanet would have been an object early in solar system history that was growing, getting much larger, and some of those protoplanets would have gone on to become the planets that we see in our solar system today, like we're standing on Earth here. And some of those other protoplanets may have collided with others and merged to form bigger protoplanets. And some of them may have collided and broken apart. And some of that debris from them breaking apart is still left over in the asteroid belt.
Great, thank you. And Rajavel T on YouTube asks, is Psyche a magnetic planet? Will it have the potential to save water molecules from solar winds? Rona?
Oh, very interesting question. Uh, well, if it is magnetized, it may be able to protect its own surface from the solar wind. However, it is very low chance, if at all, that it has water molecules around its surface. We have very low gravity compared to the Earth. Even the moon has very, very little water molecules hovering around its surface, very hard to detect. So we don't believe an object like Psyche would likely have water molecules around it. But Psyche's magnetic field will definitely, if it exists, will definitely be able to shield it, at least in part, from the solar radiation, solar wind, and cosmic rays.
And we're still getting some great questions that are coming in. A viewer on YouTube is asking, what is the diameter and the gravity of the Psyche asteroid? Carver, do you know that one?
Rhoda, you just gave the size a minute ago. Do you want to?
Diameter is 250 kilometers. I don't know, it's in miles, but it's basically the size of Massachusetts. And I don't know about the gravity. Maybe Carver can estimate.
We could
Very,
maybe get
very
back
low.
to them.
Yeah.
Well, that was a great question from this viewer. We will get back to you with that answer too. Thank you. And I really do like when you put it in like that size method, the size of Massachusetts. That really adds like some great perspective on it. Bonnie on Facebook asks, if the inner core of a planet was going through space, what would you call it? An asteroid or something else?
We'll call it Psyche.
That's a perfect answer. Kevin Cook on YouTube wants to know, how close will the spacecraft come to the Psyche asteroid?
I think the closest approach is around 70 kilometers.
Thank you. And then a viewer wants to know, what is the amount of material within the asteroid belt be enough to form a planet? What is the possibility that the belt is a transition phase like Saturn's rings? Carver?
So there's not enough mass in the asteroid belt to form a planet, even of like the size of Mars. There's just not that much material left over there. And we see a lot of surfaces on some of these asteroids that are very old and have a lot of craters from previous missions, like the Dawn spacecraft that went to visit the asteroid Vesta. So we know that there's a lot of these asteroids that have been there for all of solar system history. And it's not something that's actively like forming and creating new planets there right now. These are literally just the leftovers from these processes that happened when all the planets were forming billions of years ago.
And I think I have a follow-up question for you. Shalom Hammer on YouTube asks, does Psyche have any moons?
It does not have any moons that we know of at this time. We wouldn't expect there to be any that we like haven't seen yet, unless there's maybe just some very small debris kind of trapped around in orbit. But we haven't seen any moons at Psyche.
All right, thank you, Carver. And we have another question coming in from J2X on X is asking, it is an interesting mission, no two ways about it, but what does NASA plan to do with the data following a successful mission? Further research and understanding only, or a basis for follow-on missions to similar objects? Rona?
That's an excellent question. So we are explorers. We always think about the next mission. So every mission every planet that we visit, every object that we visit, all the information is gathered, is analyzed by the scientists that built the instruments and being then distributed to the public. So you can actually go on NASA websites and download all the data from previous missions. And then you and everybody around the world can think about what would be the next question, the next object we would be going to explore. And even before then, when we plan a mission, we only plan it to so many years, a few years of orbiting the asteroid Psyche, for example. But if the spacecraft remains intact, we always think about, oh, if we actually survive those first 2 years, what are we going to do next? Are we going to land on the object? Are we going to go visit another object? And almost every mission in the recent years that you've seen actually extended itself and chose another target. So you don't even have to wait for the next mission. We'll just keep exploring with the spacecraft that we have, hopefully.
Those are some exciting possibilities. Carver, do you have anything to add?
No, that was a great answer.
Perfect. We'll go on to Space Guy on YouTube. Why Psyche? Aren't there any closer asteroids that could be visited? Give that one to you, Carver.
Sure. I mean, the thing that makes Psyche special is it is the largest metallic asteroid that we know of in our solar system. We don't know of any other large object like this that we could go visit. And so if we want to understand what Psyche is, what these metallic asteroids are, and what their relationship is to the Earth and its core, this is the place to go.
Great. And Sana No Man on YouTube asks, how was the Psyche mission planned? I'll give that one to you, Rona.
Well, it's an interesting story. So at first, the idea was that we've seen a lot of different types of asteroids. We've seen the asteroids that are rocky, the asteroids that are metallic, and there was a big question that was, are they coming from the same parent body? Did they used to be the same body in the past? Or actually, are we seeing separate bodies that evolved completely separately? And then the idea emerged that maybe what's called partially differentiated bodies. It's a very big term to say that maybe some planets that are some planetary bodies that evolved didn't come as in the flavor of core mantle crust like our planet, but maybe they were kind of something in between, just like a core and a mantle or something like that. And then if that was correct, then maybe some of the meteorites that we are seeing and some of the asteroids that we are seeing were all part of those bodies that were only like partially becoming a planet. And in order to address this question, the Jet Propulsion Laboratory at NASA approached the scientists that started this mission, Professor Lindy Elkins Stanton, Ben Weiss, and others, and asked them, how will we design a mission that would actually answer that question? And that started the whole idea of bringing together all the people that can build spacecraft, can build instruments, can address other science questions, and build this mission together.
Wow, it's so great to hear about the process that went into putting this mission together. And I just want to thank you both again for answering such great questions that are coming in. And please keep sending more our way. Our experts are going to be right back to answer some of your questions. But right now, a closer look at how the Psyche mission team is preparing for the targeted October 5th launch.
There aren't many classes of objects left in our solar system that we haven't looked at up close with a spacecraft. And one of them that's left is the metal asteroids.
16 Psyche is an asteroid that orbits the sun out between Mars and Jupiter.
The reason that Psyche is unique is that it is metal rich.
It's believed that it may be a remnant core of an early planetesimal that was formed in the very, very earliest parts of the formation of the solar system.
And after this planet started forming and this metal core formed inside of that, it collided with other bodies that then stripped off the rocky mantle, leaving this core in place.
This is the part of planets that we can't sample directly today.
It's too hot, the pressure's too high, our instruments would melt. Can't drill a hole that deep in the Earth or other planets. So how do we study the core of our planet?
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do, and it would be the first metal object that humankind has ever visited.
After launch, we cruise through interplanetary space for a number of years. First, we fly by Mars for gravity assist that'll slingshot us into the asteroid belt. And then we're thrusting all the way from there to finally arriving at Psyche.
We'll go into 4 orbits to collect the necessary measurements that we need from our 3 primary instruments.
So our payload consists of a couple of imagers, which are cameras that take pictures of Psyche. Also a gamma ray neutron spectrometer, which allows us to measure the elemental composition of the surface of Psyche. And then a magnetometer, which will allow us to detect any magnetic field that's left at Psyche.
If Psyche still has some sort of remnant magnetic field, that probably tells us it really was a core. It's a strong indicator. We also use the radio on the spacecraft as an instrument, so we can map out the gravity and map out the interior structure that way.
We're using a particular thruster technology, Hall effect thruster technology. They operate 5 times more efficiently than normal rockets, so they use a lot less fuel, and is what allows us to get into orbit around this asteroid.
Solar electric propulsion has been around for quite a while, and it has flown before, but we're continuing to push the boundaries. We're going to have big 5-panel fold-out solar panels that will provide the electricity for the thrusters, which use as propellant the noble gas xenon.
This will be the first time that Hall effect thrusters have flown in deep space.
Studying the evolution of a planetary body is a detective story.
There's a magic, too, when you actually are on the launch pad and you say, we're go for launch.
And you feel like singing and dancing, and you feel like throwing up at the same time.
Let's go discover things about our solar system that we have no other way to do. I think that it's fundamental to who we are and also who we should be. It's an incredible opportunity to be a part of the team making that happen.
It is great hearing about the mission and what it will discover, and it seems like many of our viewers are feeling the same way. We have lots of questions still coming in, so let's get to a few more. Our next question comes from Ding Panda on YouTube, who asks, will the data collected be immediate release to the public? If not released as it's received, when will the data be released? Rona, do you want to take that one?
We have a turnaround of just a few weeks. So we just have to make sure that the data is clean and organized and processed correctly, and it's released fairly quickly.
And then we have a viewer on X asking, what will happen to the spacecraft upon mission completion? Carver, do you know?
Sure. I mean, right now, we don't know. There's going to be about a 2-year period of science operations as we're moving closer and closer. And then kind of as Rona was talking about a little bit earlier, once we get to the end of that period of time, then there'll be discussions about, okay, well, what do we do now with everything that we've learned over this amount of time and looking at how much fuel's left on the spacecraft. There'll be conversations then to try and figure out what those next steps might be. But we don't know how the mission will end at this point.
Still a question mark. So Bubo Science on S asks, metal rich, which metals are expected to be found? Rona, do you want to take that question?
Sure. We mostly think about iron and nickel when we talk about Psyche. We know from how light is reflected off the surface, as we explained before in the beginning, that it does have a lot of metal content. We don't know how much. We don't know if it's only at the surface, mostly inside of the body, but it's mostly iron and nickel and minerals that contain iron and nickel.
And Rona, I think we answered this question beforehand, but if you're just tuning in, Bonnie Seeberger on Facebook asks, how close will the craft get to Psyche in its orbit? Is this something we might have to get back to them?
It's around 70 kilometers, so a little bit less than Psyche's actual radius. So Psyche's radius is 113 kilometers. Its diameter is twice that, almost the size of Massachusetts. And we are going to be close as around a little bit less than its own radius. So we're going to see it pretty close up.
Very nice. And Sojourner on Facebook wants to know, will the Psyche module be collecting any other images or taking any other measurements on its journey to the asteroid? Carver, would you like that question?
I'm not aware of it. Rona, do you have anything?
Yes. So the minute we launch, we go through a process where we turn on all of our instruments one by one, a few days apart, and we start measuring from the very beginning. For the magnetometer, we will be measuring the solar wind magnetic field all the way in the several years of cruise, and we're going to be analyzing it and looking at how eruptions from the sun transverse our spacecraft. We'll also be doing a Mars flyby, so we'll be flying by Mars in order to get some gravity going and get us to the asteroid faster. So when we get closer to Mars, we're definitely going to use that as a science opportunity and use our instruments to measure Mars's environment.
Thank you, Rona. Now, we have a question from Dawn on Facebook who asks, of all the words in the world, the language, why call it Psyche? I don't know which one of you wants to take that one first.
Well, it's actually called officially 16 Psyche, and the 16 there is actually the number of how many asteroids were discovered. So it was the number 16. So that kind of tells you how far away in history it was named that way. So no one living today was involved in giving it that name. And it was called Psyche after the soul of the humans. And its astronomical symbol is actually a butterfly wing, which is kind of an allusion to a soul. And that's just the name that was given to it back in the day by the observatory in Torino in Italy that observed it for the first time.
Wow, that's a great story on its history. Thank you, Rona. And Mohammed on Facebook wants to know, how fast is Psyche's day or year? Maybe day? I'm not quite sure how we can interpret that. Rona, do you have an idea?
Yeah, so the day, as Carver mentioned about the seasons earlier on in the broadcast, Psyche is actually tilted on its rotation axis is tilted on the plane where it orbits the sun. So it always has one half pointing towards the sun. It does rotate around itself in a period of 4 hours. So you could say that's our day. But as I said, because the rotation axis is actually lying down, you always have the north basically pointing towards the sun and the south pointing towards the away from it. And then you have to wait in Psyche's year as the object is orbiting the sun, and then a different part of it will be facing the sun. So, but in 4 hours, we have a full rotation.
Wow, 4 hours. And Carver, I have a question for you. Kayla Wardle on YouTube asks, does the Psyche asteroid actually have the 2 craters depicted in the picture? If so, how did you determine the craters are there?
Yeah, so what we see right now with the radar data from Arecibo, where they're bouncing these radar signals off of Psyche and listening to those returns, is we can see that there are divots, that this is not just a smooth, round sphere. It has a very complicated shape. And it does look like there's probably two big-ish craters or big divots of some kind near the southern pole. But we don't know exactly what those look like yet, because again, right now, all of our images are very fuzzy, essentially, very low resolution view of what the shape of Psyche looks like. So they may look quite different from how we have artists imagining it right now, or maybe it'll look pretty similar with 2 large craters there, like we see on some other asteroids, like Vesta, which has a very large crater near its southern pole as well.
I'm really excited to see those first pictures come in and see how accurate the artist illustration was. And Danielle on YouTube asks, why is there such an increase in the number of these smaller bodies found more than years ago? With them being so small compared to planets, how do we detect them in the first place? Rona?
Excellent question. The short answer is technology. We have better telescopes. We have better computer programs that can detect very small signals. So we are able to do the unimaginable of seeing planets in faraway solar systems, and really just by analyzing the light that's coming off of their stars. So you can imagine what kind of sensitivity we have been building in the last few years. And we're just able to divert more resources, computer and telescope resources, to detect those bodies. And of course, there is the interest of planetary safety, of monitoring asteroids that may transverse orbit and they may present a risk. So there's definitely a lot of effort put into tracking down the tiniest body, because the tiniest body can produce a lot of damage if it comes our way.
Yes, thank you, Rona. And Elaine Hughes on X asks, is there an instrument to measure density or variances of gravitational field on Psyche?
In a sense, there is. So the main radio dish that we use to communicate all the data back to Earth, we can also use to track the spacecraft really precisely. So as the spacecraft is going in its orbit, it's getting tugged on by Psyche. And if there's a large density difference, a large mountain nearby, it's going to feel that tug at Psyche's surface. We can measure that and see, what does the detailed gravity of Psyche look like? What are those density variations within Psyche itself? And see what that tells us about how Psyche is put together, what it's made out of.
Thank you, Carver. And we know that lots of people are still joining in to the broadcast and learning about the Psyche mission with us in real time. So Kevin Brent Cook has a question we've touched on before, but since he's just tuning in, Rona, how close will the Psyche probe come to the asteroid?
Yes, so the Psyche probe will start orbiting the asteroid a few hundreds of kilometers above the surface, but then it would slowly go into increasingly smaller orbits, as you can see here. And you can see some of them are tilted in a different orientation. So the closest one is the one that you see that's vertical. That's what we call orbit D, and that's the closest one, and that's about 70 kilometers above the surface.
Thank you. And another question we touched on before, Tamir Roz on YouTube asks, how long will the spacecraft study the Psyche asteroid? Carver?
The main mission is planned to be a little over 2 years in orbit, starting with that high orbit that Rona's talking about, slowly getting closer and closer to the surface as we learn more.
And then another question from Tomer on YouTube. Could the Psyche asteroid collide with Earth? Carver?
So the Psyche asteroid has been out in the asteroid belt between Mars and Jupiter for all of solar system history. It looks to be on an incredibly stable orbit, so it's not going to ever cross Earth's orbit and have any chance of colliding with the Earth.
Great, thank you. And then Professor Marco Nunez George from the Aerospace Academy of Mexico asks, how is it possible to bring some STEM activity or STEAM activity to middle school classrooms about the Psyche mission? Rona, Carver, would you both like to take that one?
That is an excellent question. Psyche actually has a huge effort when it comes to outreach and education. And if you would like to contact us, Cassie Bowman, that was involved in this podcast, will be able to share a lot of opportunities and different initiatives that the Psyche mission has, from college students and elementary school and middle school children that we are involved with.
This would be a fantastic mission to learn about. And Dawn on YouTube asks, does the team anticipate the possibility of discovering previously unknown or undiscovered elements on Psyche? Carver?
We don't expect to find new types of elements that we haven't seen other places in the solar system before, created in our labs before. What we expect to see is kind of different combinations on the surface. The minerals that we find are going to be minerals that we've seen other places before, but it's how they're put together that's going to tell us the story of Psyche and how it got to be the way it is.
Great. And we have another question about launch. I'll see if we can answer this one. Crash on YouTube asks, how long is the launch window? I know it's instantaneous, but how many days do we have a chance? I'm already expecting to spend some time at the Cape. That's great to hear. Rona, Carver, do one of you have an answer?
Well, we're all planning and excitedly waiting to spending some time on the Cape. So the launch window for each day is very, very short. We plan to launch around 10 a.m., 10:30 a.m. And if the conditions do not permit it, we're just going to skip to the next day. I think the entirety of the launch opportunity is about 3 to 4 weeks, but I can double check.
Yeah, we'll get back to you with an answer. Thank you, Crash. I'm excited for you to go to the Cape. And I just want to say that we are actually running out of time, but I do have one final question for both of you. You know, we have lots of viewers today interested in the work both of you are doing. What advice do you have for people who may want to get involved in scientific research? Carver, we'll start with you.
Yeah, so I think the biggest piece of advice ask lots of questions. Be really curious about the world around you and dig in and try to find these answers and keep poking and asking those good questions, because that'll drive you to, working in trying to find answers to those questions.
Curiosity. And Rona, what about you?
Definitely, I'll double down on curiosity, remain curious, cultivate your curiosity, follow it, and also be creative about it. There is no single way to be part of the space exploration community. That you don't have to be a physicist or astrophysicist or an engineer. There are many different ways in which you can participate in this great human adventure. And always look for opportunities and seize them when they come your way, because that's really important.
That's a great point. Space is for everyone. I'd like to thank you both individually. Thank you, Dr. Carver Beerson, for your time today.
Thank you so much for having me.
And then Dr. Rona Oran, thank you again for your time.
Thank you so much.
No, it was a pleasure talking to both of you and learning about the Psyche mission. I'd like to also thank everyone tuning in online. I love that we were able to answer so many interesting questions. We hope you'll keep following NASA's efforts to study these mysterious worlds. To stay updated, follow NASA Solar System on Facebook, X, and Instagram. To learn more about Psyche and stay updated on its October 5th launch, visit nasa.gov/psyche. And if you're a social media creator interested in attending the launch and getting a behind the scenes look at NASA's Kennedy Space Center, submit an application for our 2-day in-person NASA social. Applications are now open, and the deadline to apply is noon Eastern Time on Monday, August 28th. Thank you again, and see you next time.